Hi, everyone. Welcome to our 1 o'clock session in the Machine Learning in Finance Summit. So this talk is actually a really, really interesting one. It's about building real-time ML pipelines for fraud detection. And I've encountered this use case actually a few times in my life, not in the space of fraud, but in the space of social media, as well as one in retail. So I think the challenges with a pipeline like this is all about how do you do everything that you can do in a batch processing, which is feature engineering, data ingestion, but how do you do it really, really fast and still meet all your SLAs? So I'm really happy to have Adi today, who's from Iguazio. He's the VP of Product to really talk about this topic. Adi has over 20 years of experience as an executive, as a product manager, as an entrepreneur. As the VP of Product at Iguazio, he owns the data platform, builds it for production, builds real-time use cases on it. He also leads the product roadmap and strategy. He's also had previous roles that span Dell EMC, ZetaPoint, and Infograte. And Adi holds a BA in Business Administration and Information Technology from the College of Management Academic Studies. So I'm really excited to have Adi, and I'm really looking forward to learning more about this use case. Adi, please take it away.
All right, thank you very much. And hi, everyone. Thanks for joining this session. So again, my name is Adi Irstein. I'm from Iguazio. And in this session, I'm going to talk about how to build machine learning pipeline with real-time feature engineering in the context of fraud detection. Now, in the finance sector, it's not all about fraud detection. You have other use cases like trade optimization, risk management, real-time recommendation engine, operational efficiency, predictions of all kinds of things like insurance pricing and so on and so forth. So the concepts that we're going to cover today are also relevant for all those use cases as well. So everything that has to do with building real-time feature engineering is not only relevant for fraud detection, but it's also relevant for other use cases as well. Now, as we all know, customers are investing a lot of time, lots of resources in order to put together a machine learning team, to put together a machine learning practices. So at the end of the day, they can come up with business services that are based on machine learning. But the reality is that most of those projects are actually failing to go all the way down from research to production. There are lots of challenges around that, lots of investments in that area, but the reality is not so great. So we're going to talk about those challenges, and especially the data challenge that has to do with feature engineering, and more specifically around real-time feature engineering. But before we touch the technical challenges, I just want to point out some of those business challenges, if you may, that has to do with developing those type of pipelines. Because at the end of the day, it's not just the technical part, it's also the business part. And what we are seeing is that in many organizations, there's still silos, right? We have different disciplines like data scientists and machine learning engineers and DevOps guys that are working in different teams using different tools, different libraries. They may have different goals, different timelines, different set of expectations. And at the end of the day, it's really challenging to align everybody to create this machine learning pipeline in an efficient way. And on top of that, you also need to take care of things like security and networking and management and logs and all those type of things. So at the end of the day, I think organization needs to come up with a strategy where they can better align all those disciplines together in order to support the ability to create a proper machine learning pipeline. And that's what we call a machine learning factory. So the idea is not just to create a pipeline once, but you want to create some kind of a machine learning factory where you can generate more and more machine learning models as an ongoing basis. Now, if you think about the hardest part of building those type of pipeline, it's mainly around the data, right? So you have data that resides on different data sources. You may have the data in your database or in your object store. And at the end of the day, you have raw set of data, and you need to take that raw data and create features out of it. So those features could be sliding windows aggregation, could be all kinds of complex transformation that you may need to create. You may need to join different data sets, filter the data. So at the end of the day, you create features, and those features could be static features like age and address and things along those lines, but they can also be dynamic features, to calculate the average amount of transaction in the last 5 minutes or last hour, and so on and so forth. And those features needs to be available for both training and for the serving. And there's also aspect of monitoring and governance. So at the end of the day, you need to make sure that this process is something that you can monitor and identify if there is a drift within those features. Now, how you can take those engineering part, the feature engineering part, all the way from your research to production. So it's one thing to develop the feature engineering in your development environment and do it in batch, but it makes it much more difficult to actually take it to production and do it in real time. So for instance, in real-time feature engineering, you need to calculate features pretty fast with very low requirements in terms of response time. So if you think about calculating z-score, which is very popular in those type of use cases, you need to take the current value, let's say the transaction amount, for instance, minus the average amount in the last 5 minutes, the last hour, or whatever window that you want to work with, and then divide it by standard deviation. And those are sliding windows, and those are moving along the time. All right. So it makes it much more difficult to do it in real time by listening to live events and calculating those type of calculations like z-score. Now, on top of that, you may want to create a feature vector that is enriched with data that is coming from the batch processing, the offline processing, like the user score. So you want to create a wide feature vector with a dynamics feature sets like z-score, and in addition to add features like scoring of the user and create a wide feature vector that can be used in your serving environment. Now, how do you do that in production? How do you do it in an operational pipeline and not just in the research environment? This is what it's all about. And those are the challenges that many customers are facing. So in Iguazio, we basically created a data science platform where the idea is to make this process much easier, much smooth. And that's what I'm going to show you later on in the demo. So the concept is basically to have a platform where you can collect any kinds of data. So it could be structured, it could be unstructured, could be data that comes from your offline databases or transactional databases, as well as data that is coming from your streaming engine, Kafka, Kinesis, whatever you, and then do the feature engineering part in a very easy but scalable way. So you can take the raw data, do the feature transformation, extract the features, create the models, train the model, validate the model that you need to essentially use in production, and then take the entire pipeline, the feature engineering part, and the model itself, and deploy it in a way that it can be scalable and access those features that you just created as part of this pipeline. So at the heart of the solution, we have something that is called Feature Store. And the Feature Store is basically, in a very high level, it provides you a single pane of glass where you can manage all of your features. You can create features, you can share features, collaborate between different disciplines in the organization, and we use those features again and again and again. But in addition to having the feature set or the feature store as a catalog, it also provides you a very robust transformation service. So using a very simple API, now the data scientist can actually create all kinds of complex transformation. You can do those sliding windows, you can filter the data, you can join different sets of data, you can take data from your database, from your streaming engine, and basically join them together. And the cool thing about it is that you create this logic once, and you don't need to rewrite the logic again. So when you go to production, and I'm going to show you that in the demo later on, you don't need to rewrite the code. You have this logic once, and you just deploy an ingestion service, and those features are going to be exposed to your training environment and also for your serving environment. So when you store the data in the feature store, it basically stores the data in an offline feature store, which is usually in your Parquet files, and that is being used for training or analytics queries. And it also stores the data in an online feature store, which is an online database for very quick serving. Now, when you do that, it's not only accelerate the time that it takes you to do the feature engineering, but it also making sure that you avoid the train serve skew that you may have if you need to rewrite the code again. Another benefit of it is that once you have the features that were trained in the feature store, you can actually compare those features to the features that are being sent in the production environment. So when you have a model monitoring in place, you can actually look and compare the features that are coming into the production model with the features that were trained in your feature store and identify if there are any drift as opposed to, based on a data drift. And that feature store basically provides you a way to do the development phase and also the serving phase. So this is a very critical component within the solution. So before I jump into the demo, I just want to give you some high-level illustration about what it's all about. And in this demo, I'm going to show you how to create feature sets that get data from transactional data sets, like all kinds of credit card transactions, and then events. Ingest those into the feature store, and then using your IDE or Jupyter, you can explore the data, you can do feature selection, train the model, do the back and forth between the model training and the feature engineering, the feature selection, and then come up with a model that you're happy with and deploy that model and the entire pipeline with the feature store and the feature set in your inference environment. So the idea is basically to smooth that process of deploying the feature engineering part and the model into production. So the same type of transformation, same type of graph that you did in your development environment is going to be applicable in production in a very easy way. And then you have a model that can get the data from the feature store and serve your model in the inference layer. So that's the idea that I'm going to show you in a second. So let's go to the demo. So what you can see here is the Iguazio dashboard. So we have all the projects that are running in my cluster, but we're going to focus on the fraud project. So everything here is in the context of a project. Once you drill down from a project, you get to see all kinds of information, operational information about the project, the models that are part of it, the feature store itself that has the feature sets and the feature vector, all kinds of artifacts and files that are part of the project, the jobs and the workflow, so things like the training of the data, feature selection, testing the models, all those type of jobs that are running in the project are part of the jobs and workflow. Then you have the real-time functions. Those are the functions that are actually running the models and doing the inference part. And then there are other assets in this project. So let's get started. I'm going to the Jupyter notebook. And what I'm going to show you now in this notebook is how you can actually create the feature sets. So we're going to create 3 feature sets. One is the transactions. The transaction is basically the feature set that keep the source, which is the user data, with all kinds of properties like target and device and other features. And then we have another feature set, which is basically represents the events that are happening. Events could be password change or last login, things along those lines. And those are feature sets that we're going to create based on CSV and then convert it into something that can be deployed in production and actually change the source in a way that it can listen to a streaming engine. Then the third feature set is the label feature set. This is more like an offline feature set that is used only for the training. So we don't need that for the online inference. So I'm going to show you how you can actually create that just for the training part. So we're working in this context of the fraud demo project. The first thing that we want to do is to get the data, get the CSV file. So this is the file that we're going to use. This is how it looks like. We have the source. This is the party name or the username. Then we have all kinds of features like target and device, the fraud column, which is the label column, the amount of the transaction, categories, zip, age, and so on and so forth. Now, what we want to do now, we want to enrich that feature set, and we want to do a couple of things. We want to extract the timestamp and break it down to something that the machine learning model can actually work with. So we want to create features that represents hour and the day of the week. So we want to extract the timestamp and create those new features. We want to map the ages into our new feature set. We want to do some one-hot encoding on the transaction categories. So we have a set of categories. We want to apply one-hot encoding on top of them. And then we also want to create aggregations on the transaction amount. So we want to do things like average and sum and count and build sliding windows aggregation for the last 2 hours, last 12 hours, last 24 hours, and so on and so forth. And we also want to create another aggregation for the transaction per category. Now, once we define that logic, that set of data is going to go into the offline feature store and the online feature store. And that's also one of the coolest thing about it, is that you don't need to do anything in order to prepare the data for your online serving. All you need to do is to create this logic once, and then that logic basically can go to the offline feature store, which under the hood is Parquet file that can serve your training jobs. And it also goes to the online feature store, calculating the last value of each feature. So it's ready for your online survey. Now, how do you do that? We're actually leveraging our feature store that has an engine that is called Story. It's a real-time processing engine that is very robust, very suitable for real-time calculation. And in that engine, we're actually defining different steps. So the first thing that I want to do is to create a feature set that is called transactions. So this is how we do that. We just define the feature set, the name of the feature set, the entity, which is like the key. In this case, it's the source feature, the timestamp, and I may add some description. And now we want to write this graph. So we want to do one-hot encoder on the categories. So we have the list of categories here, and then we want to apply the one-hot encoder on the category and the gender. And then we create the graph. The graph comprises of a couple of things. So as I said previously, we want to take the timestamp and break it down to hour and day of the week. The only thing that we need to do is basically to use a built-in library in order to do that. It's called date extractor. So I'm taking the timestamp and breaking it down to those values. And then I want to do mapping for the age feature and apply the one-hot encoder as part of the graph. Another thing that we want to do, we want to create aggregations, right? So we want to create sliding aggregation for the last 2 hours, 12 hours, 24 hours on the amount of the transaction. And just picking those operations, average, sum, count, max. And in order to create the aggregation, this is how I basically do that. So I'm having those windows, the time windows on a sliding windows of 1 hour for this type of feature and this type of operations. Okay. Now we want to create another aggregation on top of the categories, and we want to do group by of categories, and we want to count them. So this is another feature that we are adding into the feature set, and we can actually see how the feature set graph is going to look like. So we're starting with the data source, then we're applying all those steps like a date extractor, mapping the value, one-hot encoder, aggregation, and then at the end of the day, it goes to the Parquet file and the NoSQL database as well. So now we're ready. We can run the ingestion command. By the way, I'm not running it because it's it takes some time. It's a pretty big data set. So in order to run the ingestion and actually ingest the data into the feature set, all I need to do is to run the ingest command, give it the feature set name, and under the hood, it's going to do the schema inference. And here I can see the actual feature set. So we get to see the source, which is the entity, and all those new aggregation that I just created, the amount for the amount count for the last 2 hours, 12 hours, and so on and so forth, as well as the one-hot encoding for the categories that I just added in the graph, and the time step, this breaking down of the time step to hours and day of the week. So this is the feature set of the transaction. I can go back to the user interface in my project. I can go to the feature store, and here I can see all those feature sets that are ready. There's some information about them, like what's the entity, the target, and drilling down from that feature set, the transaction feature set, I can see all the relevant metadata. So things like version and last update and entity, all that kind of stuff is basically here. And obviously the features themselves. So I can actually see the list of the features. Here is the source and all those aggregations and the features that I just created as part of the graph. Speaking about the graph, you can see the graph here in the user interface. So those are the steps. Those are the steps that we've just seen in the Jupyter notebook, the data extractor, make value, one-hot encoder, all that kind of stuff here. We can actually go to the info pane, select one of those steps, and see the actual code that is part of the graph. We can preview the data. We also run some statistics. So we have a built-in mechanism to run statistics on all of those features. We're running some histograms as well for each and every feature, and so on and so forth. So you have lots of data that you can view here in the user interface. So we have this transaction feature set. Now we want to do the same thing for the events. So again, events could be a last login, password change, details change, whatever. So we're using this CSV file here for the events, and we're going to do the same trick, but this time the graph is much more simple. We're just using the one-hot encoder for the events themselves. And then at the end of the day, we're getting this feature set that looks like that. If we go to the UI again, we get to see that features here, transformation, the preview of the data, statistics, everything is basically here. So we have the transaction feature set, we have the events feature set. Now, the third thing that we want to do is to create a feature set for the label data. Now, in this case, I'm not going to use the story engine. I'm going to use the pandas. So everyone can write, pandas data frame. It's very straightforward. So you just write your pandas data frame and you add it to the graph. And now you can actually build the feature set based on pandas. So the idea with the feature store here is to be very flexible, to support all kinds of engines. So today we support the story engine that I just showed you earlier. We support pandas, we support Spark. And for that case, we're using pandas because, again, it's a kind of an offline feature set. You don't need it for online. So it's very straightforward to do it with pandas. When it comes to real time, then the guidance is to use the story mechanism. So this is how the labels data looks like. Again, it's the same story. We are ingesting the data, and we have a feature set for labels. So we have the transactions feature set, we have the events, we have the labels data set, and now the real magic comes. I want to transform that into something that can be deployed in production. I want to expose an HTTP endpoint or listen to events that are coming from Kafka or from, in this case, Iguazio V3IO stream, but it's the same thing as like in Kafka. The only thing that I need to do is basically to deploy that as a serving, as an ingestion service. So I'm using a built-in function to do the serving. So we're defining the source. It could be HTTP in this case. We have this built-in function for serving the data. And then we're adding the stream trigger as part of the function, the serverless function. And then we're running the deploy ingestion service with that feature set, with the transaction feature set. This is the only thing that I need to do. We don't need to rewrite the logic again. And now we have the same feature set, but the source is going to be a stream engine that basically ingests the data from that stream engine. We have a serverless function that knows how to get the data using a trigger. It basically points to that streaming engine. And now once the events are coming into the serverless function, we're going through the entire graph and calculating all those features on the fly. And those features, again, are ready for online serving and for training. Now, if we go to the user interface again, we can see those real-time functions that are part of our project here. So the ingest transaction, this is the function that basically does the ingestion using all kinds of triggers, the HTTP trigger and the stream trigger. So the stream trigger could be, again, Iguazio v3 stream, or it could be a Kafka stream. So we have a serverless function, gets the data, going through that graph, this transformation graph, calculating everything, and that's ready for operational, production, pretty much, immediately, without any heavy lifting on the data engineering side. We're going to do the same thing for the events. So it's the same trick, basically, getting this function, deploying the ingestion service, and now we have a serverless function that can actually listen to a streaming event and ingesting the data into our events feature set. So we've pretty much completed this development of the feature engineering, or the first phase of the feature engineering, and now we want to go to the next step. The next step is creating the models and training the model. And training the model using the feature vector that we're going to create that is based on the features that we just created. Now, how do we define the feature vector? It's pretty straightforward. We just give the list of all the features that we want to be part of the feature vector. In this case, those are the features that are part of the transaction feature set, as well as the events. Now, when I add features across different feature sets, it basically joins them using the entity. So under the hood, it already does the join. And when I create the feature vector, and this is how we do that, we basically pass the list of the features, and we can set up the label column, and that's pretty much it. Now we have a feature set, a feature vector that comprises of the list of features. And in order to get the data for my training job, I just need to run this get offline features using the feature vector name. And in this case, what I want to do, I want to save this feature set as a Parquet file, because I want to make sure that it's persistent. Nobody's going to change that. So I'm going to use this target of Parquet file, and this is how the feature vector is going to look like. So you get to see all the aggregations here, the source column, the aggregation, the categories, and also the events features that are part of this wide feature set. Now you can do all kinds of things. You can calculate the last login versus the previous login and all that kind of stuff using those same technique. Now we have the feature vector. We can run a training job. So we can leverage one of the built-in scikit-learn function that we have in the product. So we're going to use this scikit-learn using hyperparameters. That's going to run a training job. And at the end of the day, we're going to pick and choose the best iteration based on the selector of the max accuracy. And you can view the results here in Jupyter. Or you can go to the project, go back to the user interface, and under the jobs, I'm going to see all those jobs that are part of the project. This is the training job. I can actually compare between different iteration of those jobs. And when I drill down to a specific job, I can see all the metadata, when the job was running, the parameters, the results, the input data sets that I was using. This is the features vector, the artifacts that it creates, test data sets, the results. So number 3, the iteration number 3 is the best results, logs, and everything is being captured here, as well as the code itself, by the way. So let's say that I want to do all kinds of exploration. I want to do feature selection, for example. So I can write my feature selection job. Again, I can use another model in order to do that. And then once I do the feature selection, I give it a factor of 33% or 30%, and then run the feature selection itself. It's yet another job. And the output of that job is basically a list of features that I'm going to use with my new feature vector. And again, I can go to the jobs here, to the feature extraction, and get to see all the artifacts that this job was producing. So for instance, the selected features are here, a part of this job. So now I have the list of features, the reduced list of features, and I want to create another feature vector that is based on that list. So I'm creating a feature vector with that the same name plus the name short. I'm creating the feature vector. I have a URI, and now I can fetch the data using the get offline features, and this is the list of features that I just created. Now the next step is basically to deploy an ensemble model. So I want to take a couple of models and deploy that model using the latest and greatest feature vector that I just created. So this is how we do that. And at the end of the day, we're going to have a model that comprises of an ensemble of models, actually, that is using the new feature vector. So we have a model. Now we want to deploy that model as a serving function that can be accessed by my application. How do I do that? So the first thing that I want to do is to create a classifier with predict and load. And now what we want to do is to fetch the data. How do we fetch the data in an online manner? We're using the get online feature service. It's not the get offline anymore. We're using the get online. And now if I pass the a specific source, which is the key, I get to see all those features in real time, basically. So everything is ready. All I need to do is take my serving function with the model. In this case, it's an ensemble model, so it comprises of a couple of models. I deploy those that function, and now we have a function with the model that basically gets the feature vector as the way to enrich the data. And once I get the source of the data, I can basically enrich it with the feature vector that I just created and get the results. So if I'm looking here at the example, I'm sending some JSON input, and this is how the result's going to look like. The feature vector, the enriched feature vector that is based on the feature store, and all of those calculations that I just created in the previous steps, and the output of the model, whether it's fraud or not. So that's, at the end of the day, that's the goal. So we can use a mock server locally to send those requests and see that everything is running, and then deploy those functions as a serving function. So at the end of the day, if you go back here, you can see all those functions here under the real-time nucleo functions, and those functions are actually running those models. Now, if I go to the models here, I can actually see the models that I just created. So we've created two models, right? One with the first feature vector, the other one was with the second feature vector. If we drill down from the model, again, we get to see all the metadata about that model, who created it, the code itself, the job that was actually running this model. Then we can see the preview of some of the artifacts that it generates, and then the features themselves that are associated with that model, which is a pretty cool thing, because you can actually see what is the feature vector that you're using with your model. So this is the first model, and then the second model. It's the same concept here. Now we have the model, we've deployed that model. Now we want to check what's going on with those models in my inference layer, right? So in order to do that, I can go to the model endpoints. As you can see, we have three models. Those are the ensemble that we've seen earlier. If I drill down to this specific model, again, I can see all those information, the metadata, and we also have a process to analyze the drift of that model. So as I mentioned earlier at the beginning, we have this process that can take the data or the features that were trained in the feature store, compare them with the features that were actually running in production in the model serving, And based on that, we can analyze if there is a drift. So we can complete the entire life cycle all the way from getting the raw data down to the model monitoring and drift identification. Now, in addition, we also have some additional reports in Grafana. So Grafana basically allows us to be more flexible. So as a user, you get data sets in Grafana, and you can create your own dashboards. So by default, we have a couple of dashboards where you can see all those endpoints and prediction per seconds and the latency, and then you can drill down to specific model and get to see more granular information about those models. Again, the goal here is to identify if there is a drift. So you can see the features here. We don't have too much data running in the cluster, but the idea is that you can drill down and see all the relevant information about those features all the way down to the level of the actual features. So I think what we've seen in that scenario is a full life cycle that takes you all the way from data collection. So we've seen how we can take a CSV file, create feature sets, do all those calculations, convert those feature sets from being a batch-oriented feature set to real-time. So we can ingest data using streaming, Kafka streaming, or B3 streaming, and create this real-time feature engineering. It takes you all those, through those transformation of the graph that we've seen. So we've done things like aggregation, sliding window, one-hot encoding. Then you can build a machine learning model, you can train your model, you can do all kinds of back and forth between creating the model and the feature engineering until you get to the point where you have a model that you're happy with. Then you deploy the model. When you deploy the model, you also associate that serving function to the feature vector that we've just created in order to enrich the data. And then once we have the model, the last piece is to do the model monitoring and identify if the model is running properly in terms of the operational aspects and also in terms of whether the model is drifted or not. So that's pretty much what I wanted to cover. Let's keep some time for Q&A.
Perfect. Thanks, Ali. That was a really interesting demo. I think I love how it went from a batch to a real time with almost no hustle. So I think that's actually really great. We have a few questions starting to creep up, so maybe I'll go to them first. So I think Jan has a question which says, where is the feature set package coming from?
So the feature set is not exactly package, it's the feature store, right? And the feature store is part of ML1. ML1 is an open source that we are driving. We also have the enterprise version, which is the Quasio version. And the feature sets themselves, we can store them in a couple of places. So the offline features set can be stored in an object store. It could be Quasio object store, or it could be S3 or Azure Blob, whatever you. And then the online feature set is based on a very, very fast key-value database that is part of the Quasio platform. One of the things that we're considering, by the way, is to open it up to other key-value databases, fast key-value databases like Redis, for example. So that's something that is coming up probably in the next few weeks or so.
Very, very cool. We have more questions. I feel like I have questions, but I want to wait. I want to give them a chance. So the next question is from Juan. It says, is the feature store open source? I feel like you almost answered that, right? It is. There is a version of that open source, right?
Yeah, it's part of the ML1 open source,
Yeah. And I think Juan has another question, which is, which server was the demo running on? Like, where were you running the demo on?
It's running on AWS, so we can basically deploy it anywhere. Actually, we can deploy it on VMs on-prem. We can deploy it on AWS, Azure, Google.
Very cool. And I think Sui has a question, which is the code available on GitHub? Is this example available somewhere for them to take a look?
Yeah. If you go to ML1, there is a documentation for ML1. ML1 reads the docs or docs.ml1.org, Let me just maybe share my screen again. If you go here to docs.ml1.org, you can actually see lots of documentation here. From here, you can go to the GitHub repository. You have lots of info over there in this page.
Very nice. Very, very cool. Are there any more questions? While we're waiting, maybe a question from me is, we know when we talk about real-time services, I think a big part of it is the SLA piece, right? Like in terms of how quickly you can do it. So is this something that we can control through Iguazio? Like, does a platform provide abilities to control it, or is it just more about scaling the cluster or writing better Python code, if you know what I'm saying? So is it more around that, or is it more there's something inherent in the platform that can help us kind of play around with the SLAs that are required?
Yeah, so that's a great question. So basically, one of the deployment options that we support is EKS and AKS and all those elastic, Kubernetes mechanisms. So we can actually scale up and scale down based on load. Okay. But we are also an open platform. So in a sense, if you're getting all kinds of statistics, and you've seen that we're capturing the statistics about the models and the features sets themselves, you can actually trigger all kinds of events like spinning up more nodes and things along those lines, right, based on certain thresholds. So it can go either way.
And it almost offers that as part of it, right? Like it's just more settings and playing around with. That's what it looks like. It's just very cool. Okay. So another question, another one has popped up, which is, what does the premium version provide on top of the free ML1 version?
What's the premium version? So it's the Iguazio Enterprise platform. It's basically, when it comes to in a very, very high level, the comparison between the open source and the enterprise, obviously it's around support, it's around security, user management, those type of things. All kinds of enterprise grade services are part of it, as opposed to the open source, which is a typical open source.
And Juan, to add to that, I think typically you will see that quite often in this industry, right? You do have, Databricks has an open source version, but they also have an enterprise. Like every company will have that. And I think, the premium versions are usually just better packaged, better supported, and just have a lot more bells and whistles than the open source ones. So,
exactly.
Perfect. I have one more question. I feel like we have 1 more minute, but if I will wait for another question, but I can have one more, which is, you talked about the Jupyter notebook as being the interface for the feature store. So is that are we deploying notebooks in production? Like I know there are companies doing that. So are we primarily saying, let's deploy notebooks, using Papermill or whatever that is in production, or are we saying we can also deploy other kinds of workflows on top of it that are not necessarily notebooks?
That's a great question, because our approach is actually not to deploy notebooks. So the approach is basically to take the code and to convert it into functions that are running in Kubernetes cluster in a scalable manner. So it's not about Jupyter Notebook at all. Jupyter is just a mean for me to show you the demo. But the idea is that with our open source ML1, part of it is the feature store, but another part of it is the way that you can actually take a code and run it using different runtimes. You can run it using Python at scale, using Dask, using Spark. And at the end of the day, it all runs as distributed pods on top of Kubernetes, and you're getting experiments tracking and artifact management and all those goodies as part of this service.
Okay, very cool. Very cool. I asked because I know that there's also now a push for deploying notebooks, right? Where they're saying, notebooks are really easy. Like, they're hard to version, hard to maintain, but they're saying it's really easy to write them, throw them on, a production system, and kind of, you have all of these different notebook parameterizing tools that you can use. So I was just curious. Are there any more questions? Okay, I have one last one, just because there were a minute more. Just a general question. Is Iguazio a library, or is it a platform? Like, can we take the library ourselves and then deploy it in a way that makes sense to us? Or, is it better that we go with your own deployment recommendations? Like, what is the crux of it?
Yeah, so Iguazio itself, the enterprise solution, is a platform.
Okay.
So we install the platform. We have a utility that install the platform. Again, it can run on top of VMs. It can run on top of EC2 machines in the cloud. That's the enterprise platform. And again, you can work with the open source to get things started. So the open source is ML1 open source. You can deploy it anywhere on your laptop or Kubernetes cluster, whatever.
Okay, cool. Awesome. All right, I feel like we're at time. So if there are no more questions, then I'd like to thank Adi. Thank you so much. I think this was really, for me, as I told you, I've encountered many real-time use cases before, not in fraud, but in other areas. So I was definitely very curious to see what else was done there. So thank you very much. I really appreciate your time. And I think Seher has a note there which says that that if you have further questions, then looks like there's a community at Iguazio /MLOps live/join community. So you can go there and continue the conversation. And Seher also has put up a link for the ML Run link. So do check it out. I think I'm definitely going to check it out and ask my team to take a look after this session. And of course, there's also a link for folks who are interested in open source with Enterprise. There's also a link that Seher has posted. So thank you, Seher. Thank you for supporting us along the way. So thank you, Adi, and have a good rest of the day. And thanks, everybody.
Yeah. Thank you very much. Thanks, everyone. Bye-bye.